You type a web address and hit enter. Seconds later, a website from across the world is on your screen. But what happens in those seconds? Let's find out. Simple and relatable. The easiest way to understand networking is to think of it like a modern office building. And in this building, you're sitting at your desk. Your computer is your personal desk. It's your space to work and create things. Let's say you write a memo that you want to send. Your desk is on an office floor with many other desks. This floor is your local area network, or LAN. It's a private space where all the connected devices can easily find each other. That memo you wrote is your data. When you send it, your computer breaks it down into small, manageable pieces called packets. Now, how do those packets get from your desk to your coworker's desk across the room and not to anyone else? They use a device called a switch. Think of the switch as the office floor's hyper-efficient mail cart. Every device on the floor, including your computer, has a unique physical address burned into it called a MAC address. This is like your nameplate. The switch knows the MAC address of every device plugged into it. When it receives your data packets, it looks at the destination and delivers them only to the correct desk. And just like that, you have successful local communication. But what if you need to send your memo outside the building? To get your data to the outside world, the internet, you need to go through the building's main mailroom. This is your router. The router's job is to be the single gateway between your private local network and the public internet. The router assigns a private, local IP address to every device on the floor. But for the outside world, the entire building has one single public IP address. So, when your memo is destined for the internet, the switch sends it straight to the router's mailroom. Here, the router does something clever called NAT. It takes your packet and puts its own public address on it as the return address, just like a company mailroom would. Now, your packet leaves the building and travels out onto the global network of the internet. But the internet is massive. How does your packet navigate billions of buildings to find the one single server it's looking for? It uses the Domain Name System, or DNS. This is the internet's GPS. Your router asks the DNS server, "Where can I find the server for lucidlab.com?" The DNS looks up the name and sends back the exact public IP address of the server you need to reach. With the correct address, your packet is routed through the internet and arrives at the destination server, another building just like yours. The server reads your request. It's like a giant library. It finds the web page data you asked for, packages it up, and sends it back to the only address it knows, the public IP address of your office building's router. When the packet arrives back at your router's mailroom, the router remembers your original request. Using its NAT table, it knows that this incoming data is meant for your specific desk, not anyone else's. The router forwards the packet to the switch, and the switch delivers it directly to your computer. Your computer reassembles all the packets, and just like that, the website appears on your screen. And remember, this entire round trip across cities and continents happens in the blink of an eye. So, from your local network switch to your building's router, across the internet using DNS, to a server and all the way back, that is how a network works. Understanding this flow is the key to understanding our connected digital world. If this was helpful, subscribe for more explainers from the Lucid Lab. Stay curious, stay Lucid.